Hello everyone, I'm Akhilesh and in this video I'll be talking about how to measure optical power using photodiode. Very simple circuit that you can do it yourself. Suppose you want to measure an average optical power that is coming up in your room or in front of your tube light or LED bulb, etc. How to do it? First, you need a photodetector for it, and we'll be using photodetector called SFS203 photodiode. If you look at the datasheet of it, you will find that this is a wideband photodiode. That means it had a wide spectral range. So if we consider the visible light, it has a spectral components from 400 nanometer till 700 or 750 nanometers. So this photodiode has pretty well sensitivity during this region. So if you look at the spectral sensitivity curve of it, you'll find that it has a wavelength of peak sensitivity at 850 nanometer and it has a peak sensitivity of 0.62 ampere per watt. So this is called a responsivity of the photodiode. Responsivity is nothing but the amount of photocurrent generated out of the photodiode to unit optical power incident on it. So it has a unit ampere per watt. If you look at the responsivity curve of this photodiode, it is a relative responsivity curve. That means the all responsivity values here in this graph are respect to 0.62 peak wavelength responsivity. Now, how to find out the exact value of responsivity corresponding to various components? So we'll be considering three components: red, green and blue, that is 450, 550 and 650 nanometers. From this graph, we can extract the data using various online tools called Web Plot Digitizer. The link for one such tool is given here. You can check it out. From this tool, we will extract the data point value from this graph and we'll get the relative responsivity corresponding to red, green and blue wavelengths. Now, if you multiply this relative responsivity values with 0.62, that will give you the exact value of the responsivity of these three wavelengths. Now let's take an average of it. You will get an average of this, and this average value of responsivity you will be using for your calculations. Let's consider the biasing of this diode. So this is the simplest biasing that we can have for this SFS203 photodiode. Just one resistor and a diode in reverse bias condition, and we bias it using 12 volt of supply. Now we need to find out how much is the current flowing through the photodiode so that we can find out the power. So we can measure the voltage developed across this resistor. This voltage divided by the value of this resistor will give you the current that is flowing through this diode. This current is nothing but photocurrent or IP. If we divide this photocurrent IP by the responsivity value that we just found out, this will give you the optical power out of this photodiode. So this is the simplest circuit to measure optical power using a simple photodiode. Well, this may not be the accurate solution, but it will give you the rough estimate of amount of power that you are receiving. This is the simplest power meter that you can have, which is cost effective. On the other hand, there are a lot of industrial optical power meter which are quite expensive. I hope this video helped you to understand. If you like such more content, don't forget to subscribe my channel. Thanks for watching.